Hi guys, today we're going to talk about graphical representations of data again. In lesson 3 we talked about dot plot, in lesson 4 we talked about histogram, and today we're going to talk about box plot. So what is a box plot? A box plot is a graphical representation of a data set as a box in which the data are divided into 4 intervals or quartiles. Each quartile contains approximately 25% of the data. So you have to think about box plot as a box divided into 4 parts. Each part contains 25% of the data. The first part is called Q1, or the first quartile, or 25th percentile, or lower quartile. So all these terms mean the same thing, the first quartile of that box plot. And that part or quartile contains 25% of the data. Q2, the second quartile or the median, is also the 50th percentile. These terms mean the same thing, which is the median or Q2. 50% of the data lies below that value. Q3, third quartile, 75 percentile, upper quartile. All these terms mean the same thing, which is Q3. Below that value, 75% of the data lies. So let's take a look at this example. We have a box plot in front of us. This is a box plot. So if you look at the box in the middle, this is where Q1 is, or first quartile. This is where the second quartile is, or the median. And this is where the third quartile is, or Q3. So the box contains first quartile, second quartile, and third quartile. In this example, the value of the first quartile is 70. The median, or the second quartile, is 80. The third quartile, or the value for the third quartile, is 90. Now, below the first quartile is 25% of the data. The median, or the second quartile, is 80. The third quartile, or the value for the third quartile, is 90. Now, below the first quartile is 25% of the data, and the value that the graph starts with is the minimum. So we have from the minimum to the value of the first quartile, we have 25% of the data. Now, from the second quartile to the minimum, we have 50% of the data. And from the third quartile to the minimum, we have 75% of the data. And the last value that we have here is the maximum. So 5 important statistical data summary to construct a box plot: the minimum, the first quartile, the second quartile or the median, the third quartile, and the maximum. The minimum in this box plot is 65, and the maximum is 100. This graph is also called box and whiskers. One more thing we need to know before we move on to our first example is the interquartile range, or IQR. The interquartile range is another measure for the spread or the dispersion. We talked about two values for, or two measures for the spread or dispersion. In lesson 2, we talked about the standard deviation and the range. And today we're going to talk about the third one, which is the interquartile range, or the IQR. The IQR is the difference between the third quartile and the first quartile. So basically it's Q3 or the value of Q3 minus Q1. Let's take a look at our first example so we can put all these definitions in practice. We're going to go back to the example in Mr. Paley's advanced class where we have 15 students and these are their scores. We examined these scores throughout this unit. We found the mean, the median, the range, the standard deviation, and then we made a relative frequency table to construct a dot plot. And then we did the histogram, we described the distribution. And today we're gonna look at this example again, but this time we are constructing a box plot. So I'm gonna do a relative frequency table to be able to do a box plot. So we have 74 twice. We have 95 twice. We have 85 5 times. We have 90 twice or 3 times. We have 80 3 times. So we need 5 important statistical data summaries to be able to construct a box plot. We said we need the minimum, we need the value of the first quartile, the median or second quartile, Q3 or third quartile, and the maximum. And all these values can be found in the calculator. Let's find out how. So I'm going to go to edit and then hit enter. I'm going to put my data points and the frequency in L1 and L2. So I'm going to start with 74. And then I have 95. And then I have 85. And then I have 90. And then I have 80. And then I need to put in the frequencies 2, 2, 5, 3, and 3. Now I need to hit the stats button and then go to calculate. Again, we said that this is a one variable data, so I need to choose 1. So I'm gonna have to enter, and then I want to make sure that my lists are correct. I put in the data points in L1 and I have L1 right here, and I put the frequency in L2 and I have L2 right here. If you have different lists, you can choose the second button and then choose the list that you need. After that, all you need to do is to hit enter to be able to find the values. We said that the first value is the mean, and then the 5 points that we need are the minimum, which is 74. Quartile 1 is 80. The median is 85. Quartile 3 is 90. And the maximum is 95. So the minimum is 74. The first quartile is 80. The median is 85. The third quartile is 90. And the maximum is 95. So before we do the box plot, we need to scale our number line. So I'm going to start with 74, 76, 78. So I'm going by twos. 82, 84, 86, 80, 8, 90, 92, 94, and 96. I'm going to put the minimum value, which is right here. That's 74. I'm going to put the first quartile, which is 80, right here. Then I'm going to put the median. The median is 85, which is about here. And then the third quartile is 90, which is about here. And the last value, which is the maximum, which is about here. So now I have these 5 points on the number line. The box goes through the second quartile to the third quartile, with the second quartile here in the middle. So this is my box. And now I need to do the whiskers. The whiskers go from the third quartile to the maximum and from the first quartile to the minimum. And this is my box plot. Now, to find the interquartile range, I need to subtract the value of the third quartile minus the value of the first quartile. That means the interquartile range is going to be 90 minus 80, which is equal to 10. So the interquartile range is equal to 10. If you look at the calculator, you'll find out that the value of the mean is 84.87. So now to describe the distribution, we will see that going from the minimum value, we know that most of the value is going to be going through the median or the second quartile, and then it will end at the maximum. So because most of the values are at the median, and we have this shape, you can see that looking at both sides of that line, we have almost two symmetrical sides. So that means that the distribution is symmetrical in this case. And we talked about this before, and we said when the value of the mean and the median are very close to each other, a median of 85 and the value of the mean is 84.87, and they're very, very close to each other, that means we have a symmetrical distribution. Now, do question number 2 by yourself.